Hello everyone. In previous lecture we have seen the locating devices, principle of locating the locating devices in jigs and fixtures we have seen. Also we have seen the basic principles or rules of location. Along with that we have seen the different locators, flat locator, cylindrical locator, conical locator, drill bush locator, V locator, jack pins, diamond locator. Also, in several cases, workpiece are located by pre-machined holes, that is by drilled or bored. So, we have seen in such cases locating by holes by locating it on a mandrel or plug. Okay. Now, in today's lecture, we will see the clamping. So, the clamping is accomplished by clamps. Clamps hold the workpiece which is firmly engaged with locators during operation. The clamping system should be strong enough to withstand forces developed during operations. At the same time, clamping forces should not damage the workpiece. Okay, so the clamping system should be in such a way that it should be that much strong that it should withstand force developed during operations, but at the same time the clamping force should not damage the workpiece. The timing required for loading and unloading must be as minimum as possible. So to load the workpiece to load the workpiece and unload the workpiece, it should require minimum timing. Okay, and clamping must be positive when subject to vibration, chatter, etc. Now we will see the principle of clamping. Clamps should be positioned in such a way that clamping force shall act as a strong supported part of the workpiece. Clamping on unsupported part bends the workpiece, as you can see in this figure. Okay, on this workpiece at the edge the clamp is done. So what happened? This unsupported portion caused the bend. Okay, so this that the clamp should be positioned in a proper way. Okay, that clamping force shall act as a strong on the supported part of the workpiece. Clamping system should be capable of holding the workpiece securely against the forces developed during the operation. Clamping time should be minimum by using handles, hand wheels, hand knobs, tommy bars, or knurled screws, etc. If the number of clamps are to be loosened or tightened repeatedly, then it is preferable to use hydraulic or pneumatic clamping. Why? To reduce operators' fatigue and save clamping time also. So here the clamping system should hold the workpiece properly. If it not hold the properly, then it may happen that the scratch may occur on the workpiece, or you can't perform the operation very accurately. So it should hold the workpiece securely. Also, next we will see next principle. The clamping points should be provided with sufficient radius. Okay, this radius will take care of variation in the workpiece. And spare heel pin is used to allow tilting of the clamp. Okay, as you can see, if this allows spherical heel pin some tilting of the clamps. Spherical washers between clamp and nut will take care of the misalignment between clamp surface and clamping, not due to tilting of nut. Okay, so this is what clamping variable workpiece. Now let us see the next clamp, that is clamping screws. Clamping screws are used for light clamping. As you can see the clamping screws over here. If say your workpiece is too small, at that time you can go for a figure C, that you can use only one clamping screw and one locating device. But if length is more and you are supposed to perform the operation on the side of the part, not at the middle, at that time you can go for first, where you can use the two locating pins at the bottom and one clamping screw at the top. And if you want to perform the operation at the center on the workpiece and its dimensions are more, at that time you can go for a figure B, where you can use two locating pins, two clamping screw, and you can perform the operation at the middle portion. Okay, so this is what the clamping screw uses. Now next we will see the hook bolt clamp. Okay, as name itself you can see that hook is there. So this is very simple clamping device and is only suitable for light work and where usual tip of the clamp is inconvenient. The typical hook bolt clamp you can see in the figure. So if you see here in hook bolt clamp, only the tip of the clamp is there. So at many time it is not inconvenient at many places. Okay, so let us see the next clamp, that is bridge clamp. Bridge clamp is very simple and reliable clamping device. The clamping force is applied by spring loaded nut. So here you can see this is bridge clamp. This is the bottom one is jig or fixture body on which the workpiece is mounted, and this is held by this bridge clamp. Here you can see the spring loaded nut is there. Okay, so the clamping force is applied by this nut. So bridge clamp you can see over here, it is very simple and reliable clamping device, and the clamping force is applied by spring loaded nut. Okay, here you can see at the bottom G or fixture body is there, down on that the workpiece is mounted and it held firmly by this bridge clamp, and here you can see the spring loaded nut is there. So the clamping force applied on this plate by this spring loaded nut. Okay, so here we have seen the bridge clamp. Next we are going to see the heel clamp. Okay, so here you can see this consists of rusted plate, center stud and heel. Okay, this this strap should be strengthened at the point where the hole of the stud is cut off by increasing the thickness around the hole. The design differ from simple bridge clamp in that a heel is provided at the outer end of the clamp to guide its sliding motion for loading and unloading the workpiece. Okay, here you can see the in this you can see heel is there, heel slide is there, and here you can hold the workpiece in this heel clamp. Now next that we will see the swinging strap, or it may be also called as a latch clamp. This is a special type of clamp which provides a means of entry for loading and unloading the workpiece. For this, the strap, latch or lead can be swung out from the workpiece, and here you can see in the figure the typical swing strap or latch clamp. Okay, so here just by moving this latch the workpiece is held over here. Okay, when you want to, when workpiece is loaded, to hold the workpiece it moves in this direction, then you can tighten the nut over here. When you want to unload the workpiece you can move this latch by losing this nut and you can unload the workpiece. So next clamp is C clamp. Okay, so to unload the workpiece the locking nut is unscrewed. Here you can see the locking nut is there. The locking nut is unscrewed by giving it about 1 turn and this releases the C clamp. When the clamp is removed or swing away the workpiece can freely pass over the nut. To reverse procedure is adopted for loading the workpiece. That means here is also, here first of all this lock screw is there. By loosening this nut, by losing this nut, this arm swings. You can rotate this arm just by slight movement of the slight loosening of the nut. Then you can either load and unload the workpiece. Then again you are supposed to swing this arm and tighten this nut. So in such a way C clamp uses. Okay, now let us see the next clamping by swing plates. Such clamping are simple and relatively quick in operation, but is suitable for jobs of relatively smaller size, simple shape and requiring lesser clamping force. So this is what the clamping by swing plates. So here you can see at the end the wing nut is used over here. Okay, for making the lock, and here the workpiece is kept over here and just screwing and unscrewing the clamping plate is swinged. Okay, and in such a way this clamping by swing plates works. In another example, instead of at the end the clamping force is applied at the center. Okay, here you can see just by loosening this wing nut, this can be swinged arm, this arm can be swinged. You can see on the top view. Again the job either loaded or unloaded, and after loading again the arm is swinged in this direction and you can tight this wing nut. So in such a way this clamping by swing plates can be done. Now next we are going to see the clamp that is cam operated strap clamp. So here you can see quick clamping by cam. It is very effective and very simple in operation. Some popular methods and system of clamping by cam you can see in the figure. The cam and screw type clamping system is used for clamping through some interior parts where other simple system will not have access. So here you can see the cam operated strap clamp. Here the workpiece is held over here, same. Okay, so in such a way we have seen the clamps. Now next we will see the bushes. Okay, so we call it as a jig bushing or tool guide. Sometimes the stiffness of the cutting tool may be insufficient to perform certain machining operations. Then, to locate the tool relative to the work use is made of guiding parts such as jigs, bushing, and templates. Jig bushes are used in drilling and boring. A bush fits into the hole of the jig through which the drill passes. The diameter of the bush depends on the diameter of the drill. Different type of bushes are spot welded or screwed with the jig. Sometimes the bushes for guiding tools may be of cast iron. Hardened steel bushes are always preferable for guiding drills, reamers, and taps, etc. American standard bushes are classified in three categories: press fit wearing bushes, renewable wearing bushes, linear wearing bushes. Now let us see one by one. The first one is press fit wearing bushes. These bushes are used when little importance in input on accuracy or finish, and tool used is a twisted drill. These bushings are installed directly in the jig body and are used for mainly for shot protection. These are two design of press fit bushing: plain bush, flanged bush. Okay, these are the two designs of press fit bush. Okay, now second, renewable bushes. When the guide bushes requires periodic replacement due to wear of the inside diameter of the bush, its replacement is simply by using a renewable bush. These are of flanged types and sliding fit into the linear bush, which is installed press fitted into the jig plate. The linear bush provides hardened wear resistance mating surface to the renewable bush. The renewable bushes must be prevented from rotating or lifting with the drill. One common method is to use a retaining screw. Okay, so this is what flange type headed renewable bushes. Now let us see the third one, that is linear bushes. These bushes are also known as a master bushing. These are permanently fixed to the jig body. These acts as guides for renewable type bushing. These bushes are be with or without head. Here you can see. Okay, these are also called as a master bushing, and these are permanently fixed to the jig body. So here further you can see the jig bushes, plain bush, flanged bush, screwed bush, inclined and extended bush. Fifth one is a renewable bush. Okay, so these are the bushes which uses to perform the operation like drilling, boring. Okay, so today we are